Hello, everybody. We're going to be working on our Chapter 3 content today, and we're going to be working through the 2 Python labs that I have listed in the course shell here. And there's not really a lot of information provided here about the Python language, so I'm going to give you a bunch of information because I know that we have a mix of people. So some people are at home on Zoom, some people are here in the classroom, some people are using their own gear, some people are using school gear. I will tell you first what Python is, okay, and why we're even talking about it. You know, this class is an IoT class, right, which deals with small computer-enabled devices that can do very specialized tasks that, like we've been learning. What's interesting about these devices is you can program them with computer code to do very specific tasks, right? Further, if you have one, so like the Arduinos, you know, for example, have their own coding language and tool. But if you switch over to a Raspberry Pi, the Raspberry Pi, because it's more of a true Linux computer platform, you can really do a lot more on that than you can on an Arduino, including create software, right? And one of the really popular programming languages these days, both for general computing use, real heavy in artificial intelligence, data science, application development, web programming, I'm trying to think of all the different things, and to control IoT devices is a language called Python. And when you get to work on a Raspberry Pi and you load the default operating system, it already comes with all the Python tools already pre-installed. So it's already got a Python development environment, the Python libraries, and the development kit, which is a combination of technologies that we use to create computer programs. If you've never heard of Python, Python is a programming language, and it has its own website, by the way. And the website is python.org, by the way. And it talks about everything Python. So like you can learn about the language, you can download the libraries and the tools from here. And if you have questions about how it works or whatever, you can come here. They have a really big and active community. And you know, Python, I like to think of it as kind of a language on the move right now. It has very quickly grown from a server scripting language that somebody developed to make their server admin tasks easier. So if you've ever learned about Python before, you'll have learned that this guy who used to write server scripts is like, man, the server scripting language is really difficult, right? And some of you guys are learning that in the scripting class right now. I'm going to create my own that's a little bit easier, and that way I can automate my tasks. So instead of like typing a command and waiting, I can just put in 20, 30 commands, hit a button and walk away for half a day and let it do its work and come back and all my tasks are done, right? So just clever, right? What he ended up doing is it created basically a language that was super easy to learn and got very heavily adopted in server scripting, but then kind of developed from there into a general purpose application development language that's used for so many different things. And I want you guys to listen really carefully. All this artificial intelligence stuff that is being developed right now is almost entirely done in Python. I'm not sure why, and you know why that was the language that happened. I think partially because it was really easy to work with, and because of its design and implementation, it can handle really large volumes of data and information without choking, basically. So if you want to read up on the language or explore this website here for Python, this is one place that you can come. Now, what I'm going to do here in the class, just from a practical standpoint, is I teach Python pretty frequently here in our web development and data analytics program. And I'm going to kind of transport us into one of my Python course shells here so you can kind of get a flavor for the kind of stuff that we cover in the Python course. So Eric, earlier we were talking about like possible programming classes that you might want to add as an elective. This is actually a really good choice because Python is that kind of in demand out in industry. And instead of getting like a few weeks of it like you'll get in the scripting class, this is a whole course on it. And we actually have the intro version, which is called Programming in Python. And then we have an advanced Python course also that web students are required to take. you know. So normally when I teach a programming language, and this is kind of a weird place to start the session here, is everybody wants to jump in and write code. Right? It's like, I want to write code, I want to create a video game, you know, for example, right? But programming never starts there. And this is kind of the hard part to learn. It always starts with thinking about what you're trying to do. Right? And this is really kind of the struggle in programming. And so we always have a unit in our intro level programming classes where we talk about the foundation of programming is actually problem solving. And I'm going to take it a step further and say the foundation of all of IT is problem solving. Professionally, what you guys are going to learn how to do is solve problems, either to figure out a problem for somebody else or to create something new for a situation that hasn't been created yet. But it's still that you're thinking about something that needs a solution, and how am I going to create that solution? And then here's what happens to IT people and why most of us get into this. It's like, just think about a situation with computers. Like you're on a computer, like, I don't know how to, or this thing is broken. And then what do? Okay, well, you have options. You can take the machine and throw it out in the garbage, or you hop up online and you start researching, right? Or you start asking questions. In the old days, we'd have to go to the library and look it up in books, but now you got Google, right? And you can start looking stuff up. You find YouTube channels, you find websites, you find information, you find articles, and then you start to put the pieces together and you find the solution. And when you have a solution put together in principle, then you can actuate it into reality, whether that's in a hardware form or in a coding form. But in programming, we do that all the time. So you might have a really simple problem to solve, like calculating a value of your income tax. I'm just kind of thinking of a thing. So how do you do that? Well, you have to look at the tax tables and then convert that into code so that you can type in a value and get back the thing that you're looking for. So I always tell people that problem solving is really kind of a process, and you learn about the process of problem solving. And this is really kind of fascinating. So I show this to you on purpose, but you know, what we teach our students in the Python class is this little thing that I'm highlighting right now. And I think it's really kind of curious that those screens there are not updating. You guys noticing that? The back screens aren't updating with the front screen? So don't look at those because those aren't updated. This is updated here because I'm not sure why that's happening. If you're on Zoom, you're seeing otherwise. But a number of years back, somebody figured out, and I forget the person's name, so I apologize, that if you have a logical problem to solve, all problems can be solved using one of three methods. Okay, so the classic example that I usually use to demonstrate problem solving is, I want to make cookies. That sounds really dumb. I want to make a chocolate chip cookie. Why? Because they're delicious. You know, they're chocolate, they're sweet, you know, they go great with a glass of milk. How do I, if I don't have chocolate chip cookies and I can't go to the store, how do I get chocolate chip cookies? All right, well, you follow a recipe, right? And a recipe equates to IT in the fact that a recipe is an algorithm, a series of steps that you follow to solve the problem of making a cookie. You know, I know it sounds really dumb, but a recipe is a perfect thing because you have a list of ingredients, the stuff that you need to get it done, and then the steps involved to create the cookie. Okay, so we think of a recipe typically as a process of, for example, okay, step one, gather the ingredients. Step two, preheat the oven, right? You don't want to wait to preheat the oven. You want it to be ready when the batter's ready, right? So you put the cookies right in. And then maybe you beat the eggs and add the flour and add the vanilla and the sugar and the baking soda or whatever you're putting in there, right? Add some nuts, chocolate chunks, chocolate chips, peanuts, whatever, right? And then, so that's kind of a step-by-step process. Every part of that is a step. But at some point, some of the steps are kind of repetitive. Like for example, beat the eggs. Well, you don't just stir once. You keep stirring until when? Well, until the eggs are fully mixed, right? Or if you're spooning the batter onto the cookie sheet, you repeat that process until the cookie sheet is full. So there's sequence, step by step, and repetition. And in some cases, there's selection. So for example, when I make chocolate chip cookies at home, I like to have either like pecans or walnuts or peanuts in my chocolate chip cookies, but the kids hate it, right? So with the kids, they might want to have a selection, chocolate chip cookies with or without. So, and kind of the point here is, as silly as it sounds, is that you can solve the cookie problem through a series of sequential steps, through the process of repetition and the process of selection. And that's all the problem-solving techniques that you need to create IT solutions and computer code. Really fascinating. We also use some kind of interesting tools to do that, including flowcharts where we use certain shapes, for example, or this process called pseudocoding, where that's kind of like a recipe. You write out the general steps to solve the problem, but if you figured out those steps correctly, the computer code is really easy to write because the problem's already solved. If you guys are catching my drift, you know? So how do I build a computer system? Well, that problem's already been solved. You just need the instructions and the stuff, right? You just need the ingredients and the steps, right? And then you got a computer system. You guys are catching my drift on this. All right. So you go through this process and you have your solution, and then you convert it into code, and hopefully the code works and your problem is solved. All right. But okay, so let's say we figured out what our problem is and we want to start coding, and we want to code in Python. What I'm going to do is I'm going to give you guys a link here in the chat, and that's because you're not part of this course shell here. But here it comes in the chat. It's the one I highlighted here. And you'll notice this does not come directly from the Python website. So I feel a little compelled to explain it. So if you guys want to install the Python development tools onto your computer, feel free, right? If you're sitting in front of a school computer, you can just do the work there and not have to worry about it. So you don't have to actually install this on your computer, but I'm showing you where you can do it. Now, we go to this particular distribution of Python for a reason. The Anaconda distribution takes all the default Python tools, which is the language libraries, the development kit, and the coding environment. And Python's got a coding environment built in called idle, which is the same one that's in our lab description, right? That's not the one we're using tonight, by the way. You can use it if you want. But the Anaconda distribution gathers those tools and adds a few others into the mix. One of the ones that we're going to use tonight, which is called the Spider IDE. It also includes the Jupyter Notebook and a bunch of other like little oddball tools, and it puts them all together in a package that works really well. So a lot of times when people are coding in Python, this is the version that they're using to do the work most commonly. Very particularly if you are in data science, data analytics, artificial intelligence, or general application development, you tend to download the Anaconda distribution because it's already bundled together. And once you have it installed, it just kind of works, right? So highly recommend it. Now, a little heads up for those of you taking the scripting class, depending on who you take the scripting class with, and I'm thinking mostly CSS students here. I don't know if networking and cyber students, do networking and cyber students take the scripting class? Okay, I got one yes and one no. Okay. But usually when you guys are learning Python, I'm not sure like who, it depends on who's teaching it to you. Like if you get Heather to teach it to you, she will teach it on the Apollo server. Like, so you learn command line Python. So we're gonna do a little bit of that tonight. If you learn Python in the web or the data program, we use the Spider IDE because we're creating applications mostly. But all of that is included in this distribution. Everything is possible here, So if you're looking to install a piece of software, you guys can go ahead and just hit the download thing, download the tools, install them on your computer. If you're sitting in front of a school machine, no need to do that. It's already there, right? And, you know, if you want to save the hassle of doing the install, that's my recommendation, because I don't really want to do a whole spiel on the install. All right, so that's the distribution that I recommend. Once we actually get into the lab work here, you're going to notice a couple really interesting things. All right, so I'm going to use a tool called Spider, which is Spider with a Y, Spyder. That's the tool we're going to use. But I'm going to talk a little bit about the general form of the language first, and then I'll show you how it works in the Spider IDE. And then we're going to follow the lab instructions, and then I might pepper in a couple little extras. And we're just basically, it's going to be a monkey see, monkey do thing. I'm going to do something, you do the same thing, and hopefully it works. If not, we'll make sure it does. And we're just going to follow all the steps. And at the end, we're going to create a program that's a standalone program that's going to put a message up on the screen. And if you guys succeed with that, your lab is complete. All right. So yeah, so yeah, it's gonna be nice and easy. But you know, at the same time, I kind of want to make it a little bit of fun, because you know, real frankly, I think this stuff is fun, right? Yeah. Well, you know what? And to see, even if you don't know what you're doing, it's the process. It's the process of learning it. I don't want you guys to be intimidated by it, because it's highly learnable. You know, and because Python is so popular, there's tons and tons of information out there. If you really want to dig into it, you don't even really need to go to school to learn it, frankly, if you're ambitious enough. But yeah, well, here's the thing though. But if you have a good instructor, you know, I was having this discussion about learning how to play an instrument with somebody earlier, because one of my students also plays guitar and I play guitar. And I was like, well, you know, how are your guitar lessons going? And I gave him a little adage. Well, it depends on how good your teacher is too, right? If you have a really good teacher, you might learn faster or better than if you don't, right? Or if you try to learn on your own. It's always good, you know, to have the self-motivation, but it's always good to have good guided instruction as well. Right, I'm going to go ahead and I'm going to launch the Spider IDE. So if you're on a school machine, once again, it's spelled Spyder. So go to the start menu and type that in. If you guys can see that up there, Spyder. And then. So if I want to install this at home, would I go to Anaconda, the application first, and then Spider, or just would it just install as an application? That's a good question, actually. So once you download the Anaconda distribution, Spider's on your machine, you can go right to the start menu and go directly to Spider. Yeah. Now, when you that's actually a good question, Alex, because when you download the Anaconda distribution, it actually puts a whole bunch of stuff on your machine. So just to show you, like in my apps folder here, if I look for Anaconda, you can see that it puts a bunch of things in there, right? It's not just one tool. Yes, sir. So what I was just telling, we had a question here in the classroom, like, hey, should I go ahead and install Anaconda? I'm like, well, you know, it's kind of up to you. Like, if you want to, hey, why not, right? It's not going to harm anything. But there is an option, like if you're on a computer where you don't have the space to install something, or I'm just putting it out there, if you're on like a Chromebook or something, here's an option that you can try. Yeah, there is a cloud-based IDE that you can use. Here's one that one of my students, actually a high school student, believe it or not, shared with me. I'll put it in the chat here. This is called Code Sculptor. And this just runs in the web browser. And this is kind of interesting, because basically what you do is you'd write your code here. And so I'm just going to delete all that code, and I'm just going to give you a really quick example. You know, I'm going to just type up a little quick message here, and then you hit run, and you see the output right on your screen. I know that doesn't look very impressive right now, but the fact that I can type computer code in a web browser and not have to install any software and it just works, hey, man, that's pretty cool, right? Yeah. And real frankly, this is not the only online tool that does this. It tells you a little bit about how this technology works, and this is really kind of an important piece for all of you going into IT. When you learn how to write computer code, there's basically two types of languages. There's what we call the compiled language, and what we call an interpreted language. Right? So let's explain the difference. A compiled language is a language where you write a set of instructions and then you run it through this tool called a compiler or a debugger, and then it turns that code into an executable file that you launch and run, right? And so once it's turned into an executable, it's kind of like when you download a program from the internet or load something off of a disk or double click a file that's got an exe extension to it. You can't look inside and see what makes it work. It just works, right? And so that's a compiled program. Python, however, works a little differently. It's what we call an interpreted language, meaning that there's an engine inside the computer that takes whatever command you give to Python and runs it on the fly, one command at a time. Now, that's the thinking, right? But now I want you to think about this again. This is the primary language that we're using for artificial intelligence. So artificial intelligence is running on interpreted languages. That's really kind of bizarre in and of itself because the commands are executed on the fly. Another language that operates like Python is JavaScript. JavaScript works the same way, but in your web browser. So one command at a time. So there's kind of a little bit of a correlation between those languages. So I think that's kind of an interesting piece. But Code Sculptor is one of these tools that you can use in your web browser to execute Python commands. So like if you were like, you know, the people at home, for example, Seth, Ryan, and Jake, you guys could use this tool to do the work we're doing. If you want to go ahead and download and install Anaconda, more power to you. It's not going to harm anything. In fact, what you will discover is that there's a lot of software now that's written in Python, and you have to have the Python libraries already installed on your computer in order to execute them, right? And maybe you've already encountered that. So the Python libraries might already be on your computer, strangely enough. All right, let's kind of move forward a little bit. I'm going to get over and look at, and I'll kind of maybe bop between a couple different environments here. I'll keep Code Sculptor up on the screen, but I'm going to jump over to the Spider IDE, which looks like this. Okay, so now I know that my screens on the back of the room aren't updated. I'm going to pause the video for a second. All right, so now I have the Spider IDE up on the screen. The Spider IDE is one that is included in the Anaconda distribution. And when we teach our Python classes here at Gateway in the Web and Data program, this is our preferred tool. And there's a number of reasons for it. Python is a weird language. You can actually run it from a command line, right? But I'll be real frank, that's a really cumbersome way to do things. Like if you're working on a server, that might be your only option, right? Because they might not give you an IDE or a graphical interface within which to work. You might only have a command line, so you kind of have to learn command line. Here's the fun part of it. You can actually run in command line mode right here. So for example, I can come over to this area of the screen, which is called the console, and I can do my little print statement, and I'm just kind of doing an example one here, making it a little bigger so you can see it. And then once I type in the command, I can hit enter, and it executes the command. So I told it to print hi, and it printed hi on the screen. It's really exciting stuff. Now, I know that seems really silly, but there was a day and time where that was very impressive. Really? All right. Now, the way that we're going to operate with Spider, and whenever you have what we call an integrated development environment or an IDE, like that's what Spider is, I can come over here and write my code. So I can write more than one line of code. I can write a whole bunch, right? And then I hit the little play button at the top, and the output pops up over here, or in a window if I'm creating a graphical program. So for example, I'll do the same thing that I just did. You guys can follow along if you wish. Now, if you're using Code Sculptor, you can do the same thing, by the way. I'm just printing print, parentheses, double quotes, and whatever's inside the double quotes will print out the console. And watch what I'm doing here is I'm making it really big so you can see it, right? You know, I'm doing it for the sake of the people here in the classroom. This is another reason why, like, if you're in the classroom, you know, tagging into the Zoom session and watching on the screen is helpful because it's easier to see the code. But now that I've typed the command, and in fact, I should probably make it different. I can just print, hey, what's up? You know, or whatever you want to say. Just be polite. And then you can hit the run button, the little green button up in the toolbar here. And then notice that it executes on the console, which is the command line part of the screen. Yes, Alex?
Doesn't Python, is this one the math?
Python can do math, yes, absolutely. And that's part of what we're going to do tonight. This is just a kind of a preliminary example of like kind of how it works. Now, if you're over in Code Sculptor, right, if you're doing it on the web-based thing, you can do the same thing. You can just type in your command, hit the run button, and it shows you the output.
Why doesn't it show the other part?
This is just how the tools are different. Yeah, like this one here, this console shows you what file you're running, what folder you're in, and which libraries are being executed, and then shows you the output. Code Sculptor isn't doing that. Why? Because that's what they chose. You know, I have no control over that. All right, so now I'm gonna do this now. We're gonna dig into the actual lab, and we're gonna follow along with the instructions in the lab to show you how it works. Okay. I'm going to go ahead and jump over to the course shell now, and I'm going to pull down our instructions. And here's our first lab, and I was kind of looking at this earlier. And what's kind of fascinating about this does come from the official Cisco curriculum, which builds this course. Although they've kind of renumbered the labs a little bit, so that's why we have differences in lab numbers and chapter numbers, by the way. We are, you know, they talk about where you can download this from. I showed you a different way, okay? So the instructions that I just gave you do not match what's in this document. However, I'm just putting it out there. You could also go directly to the Python website, download their default set of tools, and they have a different development environment called IDLE, which is built into the Python language. Okay. Now you might ask, okay, so why aren't you using that? And I'll be really frank, because Spider is a better tool. I mean, that's an opinion. And here's the other thing that's weird about coding. Whenever you create computer code, the code that you create is basically just plain text. It doesn't really matter what tool you're using, as long as you have the engine underneath to run it. So you catch my drift. It's kind of like, you know, which car are you taking on the road? Well, which car do you want to take on the road? You know, that's kind of the answer, right? Man, you can take a sports car, you can take a van, you can take a truck, you know, whatever. You can take a bicycle. Doesn't matter, you're still getting there. You know, one might get you there faster or better or more comfortably. You know, I'll take the one with all-wheel drive and heated seats, you know, if I have a choice, you know what I'm saying? So I'm putting this in Spider because it's got heated seats. You know, that's kind of my thinking, right? With traction control. Yeah, I've been watching all these like silly like Netflix car things, so like, don't mind me. All right, but here are options, right? So if you wanted to, you can also, here's another online environment. So this one's called Programming Online Compiler. So you can run Python on this website instead. You know, my students usually use Code Sculptor because it's really simple and it just works, right? And there's like nothing fancy you have to go through. All right. So what we're going to do now, and we're just going to start typing in commands. And I think we've done a little bit of this already, but you'll notice that this tool that they're using is not too dissimilar from what we have. There's a spot where you type your code, and there's a spot where you see the result, right? And that's really, really common. So we're going to start by doing these steps. And what I might do here, and I'm going to try to be sort of strategic, is I'm going to split my screen here so we can kind of see both at the same time. If you have two screens, it's usually best if you put stuff on separate screens, but I'm just going to walk through the commands, tell you about what it's doing, and hopefully you get it to work just like I do. If you don't, just throw your hand up or just ask or whatever. You won't really be interrupting the flow of things. This is really on a very superficial level. All right. So I'm going to split screen myself. And I don't know if you guys know this trick. All right. So if you're in Windows, if you hold down the Windows key and then press a right or left arrow button, it does this thing, right? And so it moves over to one side of the screen, and then I can choose what's going to go on the other side of the screen. And I'm going to kind of do it like this, and then you can actually adjust that a little bit so you can see both at the same time, which is what I'm doing. So I'm trying to get like both the content and the output all on the screen at the same time. So I think that works pretty well there. Now, because I'm not going to be in the mode of writing the code and then running it, we're just going to put the code in the command window and execute it. So there's a difference here, right? So the thinking here is that normally when you write like a really long computer program, you do it over on this side, and you might have like a whole bunch of instructions, 50 lines of code, 100, 1,000 lines of code, right? And then when you're all done, you hit the run button and hopefully it does what you want it to do, right? But Python's also capable, which I showed you before, where you can just type stuff over here at the prompt, hit enter, and it just runs. That's the interpreted portion of the language. So that's why I'm kind of split screening like this. I'm moving this over, and my focus is really more on this window than on the coding window, at least for right now. Yes, Alex?
Okay, so we talked about how they put the numbers next to lines because they'll tell you where you got it wrong. Where do you do that for the other side? Because that one doesn't have it.
Well, you know what? That's a really good point. So like you're really trying to point out, like, if you get something right or wrong, there's like an output screen, right? Really what they're showing you is that what's over here is what your screen will look like if you're using that particular tool. So our screen's going to look a little different, but basically what we're going to do is we're going to type the commands that are in bold, press enter, and then we should see this output. It's really important when you're looking at this document is this symbol is your command prompt indicator. That's not, you're not typing that. That's just what the command prompt looks like in that environment. In our environment, it looks like this. That's a prompt, okay? We're gonna type what's in bold and then press enter and you should get a 3. So for example, let's do the first example. 1 plus 2. Now you will notice I put spaces in between, right? Then I pressed enter, so it shows the input. Notice how it says, see, this is why Spider is a little better. It shows you the output. One's green, one's red. And what's the output? 3. Okay, so are the spaces required? No. Say that again, Anthony? Yeah, I'm typing it in this box. Yeah, right side actually. Listen to the video. So some of you might be typing on the left side of the screen, which is the code side of the screen. Yeah, that's not where you want to be. You want to be typing in the console. And so this is kind of a hard, because basically that's your interactive command prompt. This is where we write like a whole bunch of commands all at once. So what we're doing in the console, so conceptually, right, is we're just typing one command at a time and then executing.
Oh.
All right, does that make sense?
Okay, so this one is for longer tasks or longer things. That's what,
Bingo.
just to check something real quick.
Right. And the second lab that we do tonight is going to be the longer approach. And the first lab is all one at a time.
Okay.
Right. So when you're in the scripting class, I want you guys to think about this. When you guys are in that IT scripting class and you're learning how to do server scripting, the reason they use Python is normally when you run a command at a server, you run one command, you press enter, and you wait. And sometimes it goes quick, and sometimes you wait a while. right? If you're doing a backup, it might take an hour, right? If you're just like doing some math, it'll come out right away. But what if you have 1,000 commands to do? Well, you could put that all in one file and run the whole file instead of running one command at a time and waiting. See, it's just a logical thing. But we're teaching you here first how to work the command line. Now, the one point I made here was I put a space in between the 1 and the plus sign and the plus sign and the 2. And then I said, is that needed? And then in the next line, I didn't do that. Now, here's the convention though. When people are usually writing Python code, they put spaces in because it's easier for humans to read. When you put stuff like squeezed together, it becomes hard to read.
Is that only for math or also?
That applies to just about everything, actually. That's a good question. All right, let's do the next one. So they have like 2 times 4, and then they do 6 divide by 2. And some stuff that they're not doing here. So they're not doing any subtraction, by the way, but you can do subtraction. So I can do like 10 minus 5. That's possible. Yes, sir? Yeah, that. I was going to lead us there. Yeah. So Jake is asking, why does the division give me a 0.0 where the other stuff doesn't? Because here's the trick with Python. There's 2 forms of division in Python. Right? And this is true of a lot of programming languages. When you don't specify and you use a single slash, that's called standard division. It converts whatever you're doing into a floating point number. So if I was to do, for example, 2 goes into 6 evenly, so I get 3.0. But if I was dividing 6 by 5, that's not an even answer. So it gives you the capability of getting the precision. However, okay, so this is kind of interesting. If I divide 6 with 2 slashes, that's called integer division. It gives me only the whole number answer. Yeah, so Jacob, I think you might want to study programming if that one confuses you. So we're getting not the decimal point, but only the whole number version. No, it's actually a logical thing, right? And so what first prompted people to come up with this was figuring out how to make change, believe it or not. And that's really kind of the scenario. Because sometimes it's like, how many 5 times does 5 go into 6? Well, it goes into it once. We're not worried about the remainder because anything after the decimal is really a remainder. This is kind of the interesting thing. And then the other command they're not showing you here is if I divide 6 by 5, notice I'm using a percent mark, that's called the modulus operator. This is going to give me the remainder. Is that correct? It is correct. Think about this. 6 goes into 5. What's left over? 1.
Do you ask it to round up to like the 100 place or?
Yes, you can. I mean, some of that is kind of implied, but there's special commands for doing rounding. Yeah, and that's, but if you just do at least these 3 examples and everybody's getting this to work, I assume? Yeah, okay, so we're good. All right. Now, let's have it put some words on the screen. And this is kind of interesting because you'll notice when I showed you before, I used the print command and then I just typed in, okay, they say, how are you, right? And I'm doing it like this. I do a print command, I use parentheses, I put double quotes around it, and then I press enter and it does it. But I can also just say, how are you? And this is where Python gets a little weird, right? I'll be real frank. JavaScript has the same feature. I'll call it a feature, not an issue. It's a language where sometimes you can kind of guess at things and it just kind of works. Okay, makes a lot of people uncomfortable, that come from like formal programming worlds where we had to be very strict rules to get stuff on the screen. But I'm showing you that I can kind of functionally do both. But you notice that there's a difference in the output. You guys seeing the difference in the output? Here I'm telling it to actually print these specific words, and that's all it's printing. Here, what I'm really doing is I'm putting together a string of characters, and when it outputs it back with a single quote around it, indicating this is seen as one collective object, as opposed to just putting stuff on the screen. Okay, so this gets, like, we can go into computer theory on this, but both of them are getting the words on the screen, but they're a little different. And this is part of the flexibility. All right, let's move on to the next little example. And then what I'm gonna do, and I don't wanna like bombard you guys with too much information. We'll do a few of these examples and then we will take a break because we're at that halfway point, by the way. But I wanna get as much of this done as I can. So the next command says type parentheses 65 inside the parentheses. And then it says int. Okay, so here's what that means. In mathematics, counting numbers are known as integers. And you probably learned this when you were in like 4th grade or something, and then you quickly forgot it, right? Because it's like, who cares, right? Right. But counting numbers are like 1, 2, 3, 4, 5, like whole numbers that you say out loud, right? I mean, you're not usually going 42.75, you know, unless you're a total geek, right? Or if you know pi or something like that. But when we put in this keyword type, it's telling us what kind of number, or more importantly, what kind of data it is. It's an integer, right? If I do the same thing, so if I say type, and then I do 45.6, which is what they're using, and press enter, this is a floating point number. It has a decimal point in it. Right? It also, floating point numbers allow for a higher degree of accuracy, I mean, basically. Python really only thinks about numbers in 2 ways, by the way, integers and floating points. Really kind of bizarre. That's pretty unusual for a language. If you look at a programming language like Java, they have about a dozen different numeric types, all with different degrees of precision, by the way. You know, so small integers, large integers, floating points, exponents, logarithms, yada, 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 yada. It just goes on and on. All right. Another thing that you can investigate the type of is text. So I'm just putting in some nonsense text here. But when I put in text, it identifies it as str, which stands for a string of characters, right? If I put numbers inside of quotes, by the way, that's not a number, that's also a string. Really interesting thing that happens on computers, and this is kind of a bizarre feature of all interactivity with code. Whenever you type something at a keyboard, even if it's a number, it's a string. So if you ask a person like, hey, how old are you? And they type in, 29 or whatever, you press enter. To do math on the 29, the computer's got to convert it to a number first and then do the math. Interesting, right? Because everything we type at the keyboard is a string. Everything we put on the screen is also a string.
So it's a string if you put quotation marks on it?
Correct. It changes the data type, basically. Those aren't the only data types. And this is kind of interesting. There's another type of data, and I got to spell it right, called a Boolean. And you see the little abbreviation there, bool, right? And what a Boolean is a true false value. So while true is a value, false is also a value. Booleans can only have 2 states, true or false. The irony of it all is behind the scenes, all programming languages, all computers, all CPUs, all memory, all electronics operate exclusively on binary principles of true false. And it creates some really interesting issues mathematically because some numbers don't jive well with binary. So sometimes you'll do some advanced math that should give you a round answer, and instead of like it dividing to like an even number, it will divide to like the number 0.99999 repeating. Like that should be a whole number. No, that's just a byproduct of binary, imprecision, basically. Kind of an interesting little thing. You can also, right, so instead of like checking for a type, you can also do logical comparisons. So this is what these next examples are about. So I can say 1 is less than 2. Is that true or false? Well, it's true, right? Or I could just flip the sign. I could say 1 greater than 2. Well, that's false. Or is 1 less than 1? Well, that's false too. Then more interestingly, I can't say 1 equals 1. So this is kind of interesting. The equal sign in coding has a special meaning. Its meaning is to assign a value to a location in memory. If you want to check to see if something is equal, you actually use 2 equal sign. So is 1 equal to 1? That's true. Is 1 equal to 2? No, that's false, right? Okay, you can also do the compound statements. You can say is 1 greater than or equal to 2? That's false. But I could say is 1 less than or equal to 2, and that's true. So these are just what we call basic logical comparisons. So what I'd like to do now, if you guys don't mind, let's take a quick 5-minute break and we'll come back and we'll plow through the rest of this. All right, so we're doing the example here and I forgot to hit record, where here we're assigning a value to a variable, just to repeat. So the 3 gets stored in a value called x, then we can multiply x by 5 and we get 15. Then I used a regular name to store a value. I multiply the name times 2 and we get the output. That's just kind of a repeat because I didn't record it. Here's another thing, then this is really weird to Python. If I take a string, like I say, like the example in the book is like good, but I'm going to go, oh, wow, and multiply that by 5, it puts oh, wow on the screen 5 times. It's kind of strange. And then notice I didn't put an extra space in there, so the second oh, wow is right up against it. So if I really wanted to fix that, I could go like that. Oh, wow, oh, wow, 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 wow. Very unique to Python, right? And one of the reasons actually why Python does this with natural language processing, which other languages don't do. You have to like write a whole bunch of code to make that happen in other languages. All right, the next example is kind of a fun one. So they do, for example, and you can call these whatever you want. They're calling it string 1 equals, hey, you can put in whatever words you want. String 2 equals space whatever. And actually, I see they're forcing the space in manually. And I'm just going to do those 2. And then I'm going to also create a variable called space, which equals an empty string, but I am typing a space in there. And then I can just take the command that they have, which is print. And this is kind of fun. Now I don't have to put double quotes in here. I can just go string 1 plus space plus string 2. And press enter. And I have, hey, whatever. Kind of a goofy example, but hey, sometimes coding is goofy. All right, I'm going to keep cranking on this because we don't have a lot of time left. you guys? All right. Another thing that you can do here is you can actually convert. So if I take the number 5 and store it in X, I can then use a modifier to change that X into a string. You notice what just happened there? And I told you guys earlier that from a computer input and output standpoint, whenever we're inputting stuff into a program, it's always a string. Whenever we're outputting, it's always a string. Another thing that also happens is that you can do that with a floating point number too. So they say, for example, y equals 4.2. I can also convert y to a string, even though it's a floating point number. There are other conversions. So they notice with the next one, if you have somebody, like for example, if you have a user and you ask them their age, usually they're going to respond with a whole number, right? But you might get a snarky person that says, hey, I'm 29.75, not quite 30, whatever, right? And I can convert that to an integer so I can strip away the decimal point. Or, and they don't show you this one here, I can take a floating point number or take a whole number and convert it to a floating point number also, adding the dot zero. Blank lines. All right, let's just keep pressing forward on this. If you guys did what I just did here, that covers us for H as far as I'm concerned. All right, and for I. So if you guys just did what I have highlighted, convert an integer or a floating point to an integer, convert a float or an integer to a float. I'm trying to use the right terminology here. They have a few more examples in what they're doing here. I'm not really overly concerned about that. All right. Another really useful thing in Python, and we're going to use this at some point, is you can, when you run a program, how do you interact with your user? This is kind of interesting. So they have an example here, and I'm trying to zoom out a little bit. It says, where they're setting up a variable called name, so that just holds a spot in memory, and then I issue the input command, and then inside of parentheses, I prompt my user, what is your name? I'm also leaving a space at the end of it. Right, so now watch what happens when I press enter on this. It's asking me, notice it's waiting for my input is really what it's doing. So what is your name? And I'm going to say Takis. And I'm going to press enter. So I just gave the piece of information. So now we'll follow the next command, which is print hi space plus whatever name was typed in, then a quote, a comma, it is nice to meet you. And then we'll close the quote and press enter. So I'll leave this up on the screen so you guys can see it clearly. That's what it looks like. And then I'm going to press enter. So I first type this. This came up on the screen.
Yeah, mine has like little dots.
All right. Okay. All right. So if you guys are getting this message here, right? And Nasia, could you bring Spider onto the screen because it's on your other screen? And so Nasia typed in the command correctly. You guys can see she typed it in right. But then this box popped up here, right? This is a problem with some of our lab computers. Okay, so I have to put in a support ticket because there was a release of Spider that had this problem, and then I put in a ticket to fix it, and apparently they didn't fix it. So you're not doing anything wrong. So if you want proof of that, you can go over to Code Sculptor and put in that same code. So you can say name equals input. And you know what? I'm going to take the screen back so people can see what I'm doing. Yeah, so you're not doing anything wrong. And so don't worry about that little piece of it. Yeah, you can stop sharing. And I assume you guys are seeing my screen now? Yeah. Okay. So in Code Sculptor, just do the same thing. Not, and once again, not a problem with anything you did. It's a problem basically. So here it's asking me this way, but I'm typing in my name, enter. And then if you want to do the print command, you can put it all in after and you'll see print. All right, so I'm going to run this all together. I don't, it's kind of goofy, but if you're having that problem with Spider, now if you just installed Spider on your equipment today, you won't be having this problem because they fixed it. But there was one specific version, which was the version they installed at the beginning of the fall semester. Then the semester started, I put in a ticket in the lab to fix it and they never fixed it. Or they fixed it on some machines and not all of them. So I don't know whose machine it's working on and whose it's not. All right, let's finish up the example here because we're getting really close to the end of the first one. And this time we're going to go full screen. And we're going to use both sides of the coding window. You can use Code Sculptor if you want, but the goal is really, really darn simple. We're just going to do a print command. So you can clear everything out if you want. Yeah, we're going to do a print command here. And we're just going to do what's considered to be the required first program you write for every programming language, which is the hello world program. It just goes like this: print hello world inside of double quotes, and then you hit the run button. And this is how you complete the first lab. Yes. Okay, give me a second here to pause the video. All right, so if you guys just caught what I said, I just want you to screenshot this, that you got this to work, and turn that in for your lab. I'm assuming everything else you got to work is good. For this second lab exercise, if you open up this document, they kind of have a couple of parts here. So I'm going to functionally give you what I'm going to be grading. All right, so the part that I'm really going to be grading is part 2, which is create a simple game with the Python IDE. And it's basically a number guessing game, right? So it's not, don't worry, it's like not a GUI interface or anything like that with graphics. This is all text-based. But what I'm going to have you do is basically go to step B, and we're going to have you copy all the code that's on that screen. Now here's the important part, right? You cannot copy paste this, right? So there's no copy paste option. You have to type it all in. All right, so that'll take a little bit of time. If you can't finish it here, you can always finish it at home, just putting it out there, right? So here's the technique on this, and I'm gonna start typing this in. The reason I'm using Code Sculptor, just to repeat this, is because the lab computers here some of them are having problems with that input command, right? So normally I would use Spider for this, but if you're doing your own install, no problem. But otherwise, please go ahead and use the Code Sculptor website link that I just dropped into the chat. As you're typing this in, what you're going to learn about Python, and I'm not giving you like what you're learning or what you're doing here. I just want you to copy it exactly as shown, put it in there, and then run it. Okay, so that's kind of the operation here. Now, as you're typing the code in, here's some things to pay attention to. When the code is indented, you have to make sure that you also indent it the same amount. Otherwise, the code won't work. So for example, notice how some of these lines are all lined up and some of them are indented. And if you count the number of spaces, it's 4 spaces that they're using. Python's not actually that picky, but whatever amount you're indenting, you have to be consistent. Otherwise, the code breaks. All right. So I'm going to start demonstrating this. So I'm going to do the same thing I did before. I'm just going to split screen this. Oops, sorry, wrong screen. I'm going to split screen this. And then I'm going to follow along with these instructions. And then I'm going to type them into Code Sculptor over here. Right? And actually, we want to, there we go. And right now, I'm worried more about typing in the code. So I'm just going to copy this verbatim, exactly as shown, and put it on the other screen. One really important thing to note, you don't have to type the numbers at the beginning, right? That's just the line number that'll auto-create itself. So just to demonstrate, I'm going to type num input. Notice I already did a typo. And I'm going to say equals input, enter an integer between 0 and 1024. And I am kind of zoomed in here, so stuff is kind of like not fitting. And then I'm going to say num input. And you want to type it in exactly as shown. Don't change a letter from uppercase to lowercase because you want to. Type it exactly as shown, because if you start changing stuff, things will break. And I already noticed that I have an error here, so I just want you to notice. Here I type num input, and here I type num input. That would cause a problem. So you have to be consistent. Now here's what I'm going to tell you guys. This isn't due till next week, right? So if you don't get this to quite work, we can look at why next week. We're not going to probably have enough time tonight. Some of you might be able to type this all in tonight and call it a night and get it to work. Fantastic. Otherwise, no pressure. You can always do it at home. All right, so I'm going to get these typed in. So I'm on that third line now. You see, I'm zooming out here a little bit just so I can see it all. And because this is probably boring to watch in video format, I'm gonna pause the video. It shouldn't be recording me typing, right? Just in. So some of us in the classroom here did get this fully typed in, and I'm just gonna run it once here. And basically you type in a number like, for example, and then you hit enter, and then it just spits the number back on the screen. This may or may not be what you wanted it to be. Really kind of the point of it is if you're guessing for a number between 0 and 124, you wouldn't want to type like 125, right? Or a negative number, right? Those would throw errors. You know, I think what most of us anticipate is if we're doing a number guessing game, that the computer picked a number and we're trying to figure it out, and it would let you keep guessing until you get there. And so what I would normally do with my programming students for a game like this is I would have them write the rest of the code, which completes the logic, and all the logic isn't here. You know, so I'm going to get on Jerry's case about like, hey man, this isn't a complete game. This is just the start of the game. It does take your number and put it back up on the screen as long as it's between 0 and 1024. I mean, I guess that's what it's telling you to do. But my thinking is if you're playing a number guessing game, it's going to keep, you know, like, okay, well, that didn't work. Put in the next number. Let's try to figure out what number the computer picked and whatever. But this is actually the completed program working. So you guys can see the code. The real important takeaway here, and we'll revisit this next week, you know, especially considering we're not really learning how to be programmers here. We're just having fun with a little Python code, is you might have little things that are breaking the code, like if you misspell something or if you don't indent it correctly. And next week when we come together, we'll take a look at that and try to figure out whatever it is that you typed in incorrectly and fix it. All right, this video ends here, folks.